Hi, my name is Joshua Lee and I like science. I made this YouTube channel so I can share my knowledge and experience about science with you. I will try to explain concepts in a simple and easy way. I hope you enjoy. Thank you. For this video, we'll start off by learning about kinematics. Kinematics is an important branch of physics that is concerned with measuring and predicting the motion of objects. Kinematics is very important to understand since there's a lot of motion in the universe. First, we'll be learning about one-dimensional motion. To learn about one-dimensional motion, we must first learn the difference between scalar and vector quantities. Scalar quantities are ones that have a magnitude but not a direction. These include speed, distance, mass, and temperature. Vector quantities, on the other hand, have magnitude and direction. These include velocity, acceleration, and displacement. When asked for a vector quantity, remember to give magnitude and direction. An important thing to note about vector quantities for now is that since they have a direction, they can be negative. Let's talk about distance and displacement. Distance is a scalar quantity, so it doesn't have a direction. Displacement does, since it's a vector quantity. Distance is the length of a path that an object took to move. Displacement is how far an object's starting point is from its ending point. Let's say I'm standing over here, at point A. I move this way 4 meters to point B. Then I move 3 meters this way to point C. Then what was my distance and what was my displacement? Let's look for distance first. Distance is the sum of this arrow and this arrow. So that would be 4 meters plus 3 meters, which is equal to 7 meters. So the distance I traveled, my distance, is equal to 7 meters. Now let's look for displacement. Remember, displacement is how far my starting point is from my ending point. So it's the length of this dotted line right here. Now, if this was a right angle, then we can find out that this is 5 meters. So my displacement is equal to 5 meters. Now let's try another example. Let's say there's a tree and there's a fly on the tree. The fly is currently 5 meters high in the tree. Then it decides to go up 2 meters, then down 4 meters. Now what is the distance and what is the displacement? Let's look for distance. Distance is the sum of this arrow and this arrow. So it's 2 meters plus 4 meters, which is equal to 6 meters. So the distance that the fly traveled was 6 meters. Now let's look for the displacement. The displacement is how far the starting point was from the ending point. So if the fly goes up 2 meters, it's at 7 meters. Then down 4 meters, so it's at 3 meters right now. So 5 meters minus 3 meters is negative 2 meters. So the displacement was negative 2 meters. Notice that there's a negative, since the ending point is below the starting point. In physics, the up direction and the right direction are considered positive directions, and the left direction and the down direction are considered negative. Since the ending point is below the starting point, it's negative 2 meters. Now let's talk about speed and velocity. Speed is a scalar quantity, so it doesn't have a direction, but velocity does since it's a vector quantity. Some people think that they are the same thing, but they are different. Let's say I'm standing here, and this is the ground. If I walk back at 1 meters per second, then what is my speed and what is my velocity? The speed is 1 meters per second because that's how fast I'm going. But my velocity would be negative 1 meters per second since I'm going in a negative direction, because backwards is a negative direction. Remember that velocity has a direction, so this negative represents the direction. Let's say a word problem gives you a direction. This is west, so let's say he moves west. Then you would give the velocity as 1 meter per second west. Notice that there's no negative. You don't need the negative in this situation because you already gave the direction as west. Now I'll give you the equations for speed and velocity. Speed is represented as s equals d divided by t. S is speed. Here, this d is distance. This t is time. This equation makes sense since speed is relative to how much distance you cover over a certain amount of time. The equation for velocity is very similar. It's v equals capital D over t. So this v is velocity. This d is displacement. And this is still time. The only difference between these two equations is that this is displacement and this is distance. This makes sense since speed and distance are scalar quantities while velocity and displacement are vector quantities. Since displacement can be negative, velocity can also be negative. Using these equations, we can solve many problems. Now let's try to solve a problem with speed and velocity. Let's say there's a racetrack. This is the starting and finish line. There's a race car here and a race car driver. So let's say he travels one lap around the course. He travels one lap around the course, which is 7 kilometers. When he comes back, he realizes that he completed that lap in 100 seconds. So what was his speed and what was his velocity? His speed is distance over time. The distance is 7 kilometers or 7,000 meters. The time is 100 seconds. So his speed was 70 meters per second, which is about 150 miles per hour. Now let's look for the velocity. Velocity is equal to displacement over time, which is in capital D. So we need to look for displacement and time. His displacement is 0 because he ended up where he started, so he didn't really travel anywhere. So velocity is equal to 0 meters, and the time is again 100 seconds. So his velocity was 0 meters per second. The SI unit for speed and velocity is meters per second, since meters is for measuring length and second is for time. Now we'll learn about one final quantity, acceleration. But what does it mean to accelerate? Or if something is accelerating, what does that mean? A lot of people think that if something is moving fast, it is accelerating, but that's not always true. To accelerate means to change velocity over a certain period of time. So, an object that is traveling very fast at a constant speed can have zero acceleration. For the examples I use, we're going to assume that the objects are moving in a positive direction. Since acceleration is the change in velocity during a certain time, the equation for acceleration is a is equal to change in velocity over change in time. This symbol, that looks like a triangle, is the Greek letter for delta. In math and physics, it means change in. This can be simplified as a is equal to vf minus vi divided by t. The vf represents the final velocity and the vi represents the initial velocity. The t here still represents time. You can write it as delta t or just t. It doesn't matter since they represent the same value. The SI unit for acceleration is meters per second squared. To find out why s is squared, we can plug in the units for velocity and time. We get acceleration is equal to meters per second divided by second. When you're dividing by a number, you're actually multiplying the reciprocal of it. So when you're dividing by s, you're multiplying the reciprocal, which is 1 over s. So this becomes meters per second times 1 over second. So acceleration is meters per second squared. Let's try an example. Let's say a car starts from rest. Then, after 10 seconds, the car is moving at 20 meters per second. What was the acceleration? In physics, it's useful to have a list of knowns and unknowns. So, we'll write down what we know and don't know. We don't know the acceleration, so we're looking for it. We know that the time is 10 seconds. We know that the final velocity is 20 meters per second. The initial velocity is 0 since it starts at rest. Now we can plug all these values into the acceleration equation. So a is equal to 20 meters per second minus 0 meters per second divided by 10 seconds. So acceleration becomes 20 meters per second divided by 10 seconds, or 2 meters per second squared. When you get 2 meters per second squared, what this means is that for every second that passes by, the car's velocity will increase by 2 meters per second. Now let's try one last question. Let's say there's a motorcycle that's traveling at 130 meters per second. It has an acceleration of 10 meters per second squared. After 5 seconds, how fast will it be traveling? This question is a bit different since we know the acceleration and we're asked for the final velocity. Well, we can change the acceleration equation using algebra to get that Vf is equal to Vi plus At. So, let's make a list of knowns and unknowns. We know that the Vi is equal to 130 meters per second. The time is equal to 5 seconds. The acceleration is equal to 10 meters per second squared. What we're looking for is the Vf. So we can plug all these values into this equation. The Vf is equal to 130 meters per second plus 10 meters per second squared times 5 seconds. This becomes Vf is equal to 130 meters per second plus 50 meters per second. So the final velocity is equal to 180 meters per second. So after 5 seconds, it will be traveling at 180 meters per second. Today we learned about scalar and vector quantities. We learned about acceleration, distance, displacement, speed, and velocity, and how they all connect to each other. These are the most basic concepts of kinematics, and I hope you enjoyed. Stay tuned for my next video.